Okay, we're going to learn, first round of applause for your shipmates. All right, we're going to learn base 2. Base 2 is binary. Bi means 2. There's 2 options. 0 is off, and 1 is on. You want to step over here for a second? So 0 is off, 1 is on. That's why if you look at your monitor, look at the power button, it's a 0 and a 1. Binary, on and off. Good to go? Okay, so everything that a computer does is in binary, 1s and 0s. Electricity going through, electricity not going through. Does that make sense to everyone? Awesome. So we're going to have these 3. Step over there near Chief for now. So right now, what's your name again?
Bernie.
Bernie. Awesome. So Bernie, we're going to start with Bernie, and we're going to figure out how to count using binary. So right now, let's come up with a class. What's a motion we want to do to indicate that these individual people or bits are on or off? Let's not do jump because they got to stay on. Maybe a hand up? Arm circles? Arm circles. That work for everybody? Now they're going to hold the paper in their hand, so they'll just do one and you guys can alternate. That work? That okay? Yeah. So nothing, doing nothing, that's off. Arm circles is on or 1. Does that make sense? Okay. So starting with Bernie. Right now, he's off. So what is that value? 0. And if we were to turn him, so on, that would be what? So do arm circles. Now what's his value? 1. Does that make sense to everybody? Yes. All right, you can relax. All right, so we've got 0, we've got 1. Can we go any higher? No, because we only have 1 bit. So what is the value of Bernie's bit? 1. So go ahead and flip that paper over. Bernie's value is 1. Easy day? All right, let's bring in, what's your name? Corzo. Corzo's coming in. What do you think Corzo's value is? 2. 2. So flip that paper over. He is a 2. Who, yeah? All right, they are both off right now. So what does that equal? 0. All right, Bernie, on. What are we at now? 1. Bernie off. Corzo on. What are we at? 2, because the value of Corzo is 2. Corzo stay on. Bernie on. Now what are we at? 3. All right, relax. What's that? 0. Does that make sense to everybody? All right, both of them on again. What does that equal? 3. Relax. Okay, so now what we had 0 and 1 with Bernie. We got 2 and then 3 with Corzo. What would the next number be? 4. So come on over, Jackson. His number is 4. So if only Jackson is on, what does that equal? 4. Does that make sense, everyone? All right, everyone off. So let's do some counting. What are we at now? 0. 1 would be who on? Bernie. Back to 0. 2 would be Corzo. 3. Corzo and Bernie. And 4? Jackson. 5. Jackson and Bernie. Not you, Corzo. That's 5, right? All right, relax. What would 6 be? Corzo and Jackson. All right, that's 6. Now 7 would be all of them. All right, relax. What would the next number be? 8. So come on over, Watkins. Watkins is, flip it over, 8. That makes sense, everyone? So let's try something else. Let's try, what would 10 be? Corzo and Watkins. 8 plus 2 equals 10. Does that make sense to everyone? Any questions? All right, round of applause. Take your seats. Good job, guys.
Somebody cover.
So it goes from 2, 4,
1, 2, 4, 8, 16, 32, 64, 128. All right, the next few chapters we're going to do, so we're going to learn this in chapter 5 starting tomorrow, but we're going to knock it out today. Chapters 5 and 6 and a lot of CCNA. We're going to do a lot of board work. This is a difficult classroom for everyone to see with these pillars in here. So if you can't see the board, stand up with clear spaces so you can be standing up and writing along the desk. But if you can't see, make sure you come up to the board, okay? But all this stuff you'll be able to see on YouTube within a few hours after work. Good to go?
Good to go.
Okay. So binary, that's base 2. That's 0 and 1, right? Decimal is what we call base 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can I have 10? No, because that's 1 and 0. How many numbers are up here, though? 10, right? 1 through 9 is 9, but we start at 0, so 0 through 9 is 10. We're going to learn hexadecimal as well. That's base 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And A is 10. B is 11. C is 12. D is 13. E is 14. And F is 15. So that'll make more sense a little bit later, but that's why hexadecimal can do more, right? 9, we can't have 10 because that's two things, 1 and 0. A represents 10. B represents 11. C represents 12. D is 13. E and F is 15. We'll put that on hold for now, and we're going to go back to binary, and then we'll come forward to hexadecimal. Good? All right. So one individual bit is 1, right? 1 bit. A nibble is 4. Bit, nibble, and what's a byte? 1, 2, 3, 4, 5, 6, 7, 8 is a byte. With me there? So we're going to be working at the byte level, especially when we get into IP addresses tomorrow or later on this week. So what we're going to learn how to do is we're going to learn how to convert from binary into decimal and decimal to binary. So let's think back to when we had our shipmates up here. What was the value of Bernie? 1. What was the value of Corzo?
2.
And then we had Jackson, which was
4.
And then Watkins was 8. What is it doing? What is this number doing? It's doubling, right? So what would the next one be? 16. The next one would be?
32.
The next one would be?
64.
And the next one? 128. So this is our number line. You're going to need to know this very well. If you know powers, you could do powers as well. 2 to the what? 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. And 2 to the 7 is 128. I imagine not everyone is too comfortable with powers, right? So what you got to do is we start counting with what number? 1. Times 2 is? Times 2 is? 4. Times 2 is? 8. Times 2 is? 16. Times 2 is? 32. Times 2 is? 64. Times 2 is? 128. Easy day? Make sense to everyone? Okay. What value is off? 0. What value is on? 1. So if all of these are off, 4, 5, 6, 7, 8. What's the value of this bit here? Well, it's a 0, but this is a 1 if it was on, right? What's the value of this bit? 2. What's the value of this bit here? 32. So is the 128 turned on? No. Is the 16 on? Is anything on here? No. So what does this equal? 0. That equals 0. With me so far? Okay. Let's try a tricky one. What's the value of this bit? 4. So what does this equal? 4. Too easy? It's that simple. Let's do another one. Let's say I turn on this bit. What's the value of this bit? 1. What's the value of this bit? 4. So 4 plus 1 equals 5. Good to go? All right, let's see if we can figure out what this equals.
34.
Is the 128 on?
No.
Is the 64 on?
No.
Is the 32 on?
Yes.
Okay, so 32 plus, is the 16 on?
No.
8?
No.
4?
No.
2?
Yes.
Okay, 2. Is the 1 on?
No.
No. All right, so 32 plus 2 is 34. This equals 34. If it seems overly simple, it's because it is. Another one?
Yes.
All right, let's figure out what this equals. Is the 128 on?
No.
Is the 64?
Yes.
All right, so 64. Is the 32 on?
No.
Is the 16 on?
No.
Is the 8 on?
Yes.
All right, so 8. Is the 4 on?
No.
Is the 2 on?
No.
Is the 1 on?
Yes.
Yes, all right, so 1. So 64 plus 8 plus 1. What's 4 plus 8? 12 plus 1 is 13. 3. Carry the 1. 6 plus 1 is? This equals 73. So just addition. Good to go? Okay.
This is like what happened at nanoseconds or something? Like where,
So your computer works with bits, right? Zeros and ones. It's going to be processing millions of zeros and ones a second. I'm not that fast. All right. Let's learn some tricks. This equals 0. This equals 1, which is 1 less than 2 right here, right? Okay. This equals what? 3, which is 1 less than 4. This equals 4, 5, 6, 7, which is 1 less than 8. Is everyone seeing this? So what does this equal? 63, 1 less than this, right? That's 63. This equals then 127. All bits turned on. Well, we've been doubling, right? After 128, what would the next one be? 256. So all bits turned on. 1 less than that is 255. Does that make sense to everyone? Okay. Let's do some more.
That's only applicable when they're all in.
Sequence. Yeah. What does this equal? 129. 128 plus 1 equals? 129. Is this odd or even? That's odd, okay? What does this equal? 65. 64 plus 1 is? 65. Is this odd or even? Odd. What does this equal? 17. 16 plus 1 is? 17. This is? Odd, okay. And let's say I add 2. 16 plus 2 is 18 plus 1 is 19. Is this odd or even? Odd. Notice, if this bit is on, it's always going to be odd. If this bit is off, it's always going to be even. Does that make sense to everyone?
Yes.
Okay. How are we doing? Good?
Better than I expected.
Okay. So we've been doing binary to decimal. Now let's try going from decimal to binary. Someone give me a number between 0 and 255. People are saying numbers bigger than 255. 24? 28? 28. All right, 28 in decimal. All right, to convert it to binary, the first thing I need to do is write out my number line. With gusto, my number line starts with 1, 2, 4, 8, 16, 32, 64, 128. Hoo-yah? All right, now when we're figuring this out, do you think we should start with the larger or the smaller numbers? The larger. Let's see what happens if we do it with the smaller ones. 28, does 1 go into 28? No. Yeah, so minus 1, that gives us 27. Minus 2, that gives us 25. Does 4 go in there? Yep, that gives us 21. Does 8 go into 21? Minus 8, that gives us 13. 16, does that go in there? No. Oh, see, we're already out of options here. Does that make sense to everyone? Awesome. So start with the largest numbers. Just like in life, take care of the big things first. Then there'll be room for the little things. So 28. Does 128 go into 28? So that'll be off. Does 64 go into 28? So that's off. 32. Does 16? Yes. Okay, so we'll turn that on. 28 minus 16 now gives us 12. Does 8 go into 12? Yes. So 8. 12 minus 8 gives us 4. Does 4 go into 4? Yes. All day. 4 minus 4 gives us 0. Does 2 go into 0? No. So that's off. And 1? No. So 28 in decimal equals 0, 0, 0, 1, 1, 1, 0, 0 in binary. Ah. Make sense? Let's do another one. Someone give me a more challenging number. 177, is that what you said? 177? All right. 157? 177, okay. 177. The first thing I want to do is my number line. My number line is 1, 2, 4, 8, 16, 32, 64, 128. We start with the larger number. We want to solve for 177 decimal to binary. Does 128 go into 177? Yes. So that'll be on. 177 minus 128 gives us 49. That's all right. Let's do this the long way, right? Can we take 8 from 7? No. All right, so we'll make this a 6, carry the 1s. How many times does 8 go into 17? 9. Okay. Now, 6 minus 2 gives us 4. 1 minus 1 gives us 0. If you got to do the math slow, That's okay. The individual bits matter. If you're wrong, your whole answer is going to be wrong. And when we get to CCNA, we'll see why that's even more important. So 49 is what's left. Does 64 go into 49? No. So this will be off. Does 32 go into 49? Yes, so that's on. 49 minus 32 gives us 17. Does 16 go into 17? It does. 17 minus 16 gives us 1. 8? 4? 2? 1? Yes. 1 minus 1 gives me 0. So 177 in decimal equals 101100001 in binary. Is it clicking? Fantastic. Questions so far? Do we want to do another one? Yes. Okay. We want to do decimal to binary? 253? Yeah, let's do that. So we're going to do this one twice. I heard somebody say 253. What do I want to do first? Number line starts with 1, 2, 8, 16, 32, 64, 128. So let's start with the way that we've always been doing it. Does 128 go into 253? And that gives us minus 128 gives us, well, 72 gives us 200. 72 plus 53 gives us 135. Does 64 go into 135? Yes. Minus 64 gives us 71. Is it 125? Yeah, 125. Good. Okay. Does 32 go into 61? Yes. 61 minus 32 gives us 20, 29. 16? 29 minus 16 gives us 13. 8? 13 minus 8 gives us 5. 4? Yes. Gives us 1. 2? 1? Yes. All right, so that's one way we could do it. Let's look at another way we could do it. All right, my number line again. 128, 64, 32, 16, 8, 4, 2, 1. 128 goes into 253, of course, right? So we'll turn that on. What's 128 plus 64? 8 plus 4 is 12. Carry the 1. 6, 2, and 1 is, this is 192. Is 192 253? Nope. Okay. 32. Let's see if that works. Let's add 32. That gives us 224. Plus 16 gives us 240. Plus 8, 248. Plus 4, 252. Does 2? That would make it 254. Right, so we just need one more. Easy day? Let's look at one more way. Let's start with all bits turned on. What does all bits turned on equal? Not 256. 255, right? 255. So this is 255 right now. We're trying to solve for 253. How many less do we need? 2. Take the 2, turn it off, solved. Right? Because all bits turned on equals 255. All right, so that's 253, right, to take 2. All right, what if I wanted 254? 254, take the 1 away. Good to go?
So I can only go for 255.
255. All right, what about 252? If I start with 255 here, to get 252, how many less do I need? I need 3 less. 2 and 1 equal 3. We'll turn these off. That is 252. Good to go? Do we want to do any more? Good. All right, let's go to hexadecimal. Someone give me another number. 119. All right, so 119 in decimal. The first thing we need to do, solve for binary. To do that, the first thing we're going to do is number line, which starts with 1, 2, 4, 8, 16, 32, 64, 128. All right, 128, off. 64? Yeah, 64 plus 32 gives me what? 96. 16 go in there? Yeah, that now gives me what? 112. How many more do I need? 7, right? Uh-oh. We got a trick for that, don't we? Boom, 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 right? 1 less than this. These 3 are on. Easy day? So 119 in decimal equals 0.1110111 in binary. Good to go? Hexadecimal. So for our binary and our decimal, we've been working at the byte level, which is how many? 8. Hexadecimal works on the nibble, which is how many? 4. So what we're going to do is we're simply going to cut this in half. Right down the middle. Right, so let's move these bits right to where they were, 0, 1, 1, 1. Exactly the same, 0, 1, 1, 1. Now my number line for this, 1, 2, 4, 8. That's a nibble. This is a different nibble. So what do we start with here? 1, 2, 4, 8. So now let's add it up. 4 plus 2 plus 1 equals 7. 4 plus 2 plus 1 equals 7. So that's the hexadecimal value. However, we could confuse 77 with a decimal number, right? Yeah. So what we'll do is we'll put a delimiter or something in front of it to let us know that it's hexadecimal. That something to tell us that it's hexadecimal is 0x. This tells us what follows is hex or hexadecimal. Make sense? 77, 77, however you want to say it.
No, I'm saying, but like, because it's cut in half.
Each, you got to go?
Just go find the broom.
Yeah, that's fine.
Okay.
Oh, you don't need to find the broom right now. It's only 11. Don't worry about it.
Okay.
Yeah, this is a hex value. This is a hex value. Do another one?
Yeah.
All right, someone give me another number. Now let's do something. 187? Let's go higher. Bigger number. 255? 239, okay. Oh. Well, I forget. What did we say? 2 something? 239. 239? Okay. $239. What's my number line? 1, 2, 4, 8, 16, 32, 64, 128. All right, this equals 128 plus 64 gives me 192. This is 224. This would be 240. So how do I get 239 then?
Turn off the 16, turn on everything else.
There we go. Good? All right, so now we're going to convert it to hexadecimal. What do I need to do to convert it to hex? Split it in half, because hex works at the nibble. All right, we can write our numbers again here. 1, 1, 1, 0, 1, 1, 1, 1. My number line for hex. 1, 2, 4, 8. That's a nibble. This is a new nibble. So this number line is 1, 2, 4, 8. So now we're going to add 8, 4 plus 2, which equals what? 14. So do I put 14 here? No, because what does 10 equal in hex? A, 11, B, 12, C, 13, D, 14 is E, echo, 15 is F. So 14 gives us E. 8 plus 4, 12, 13, 14. 14 is echo. 8 plus 4 plus 2 plus 1, 15, right? Or one less than the next one, 16. So that gives us foxtrot, F. So 239 in decimal equals 11101111 in binary, and it equals EF in hexadecimal.
You have to put that 0.
You could, right? But it's optional here probably because we know for sure this is hexadecimal because does decimal have letters in it? It does not. Grace.
So your operating system will be writing in hexadecimal, or like?
We'll get into that later, right? You can read stuff in hexadecimal. The computer, right, on the hardware level is doing binary bits, ones and zeros. Code and other things that we're going to see later in CCNA is in hexadecimal, but everything's going to be converted to binary. Good to go? You want to do one more? Okay. Someone give me a number. 255 is FF. 248? Let's do 248. .248 in decimal. First thing I want to do, convert it to binary. To do that, we need to number line, which starts with 1, 2, 4, 8, 16, 32, 64, 128. Now you'll learn these numbers eventually through practice. This is 128. Both of these on is 192. The first three on, 192 plus 32 is 224 plus 16, 240 plus 8 is 248. For hexadecimal, we need to split it in half. 1, 1, 1, 1, 1, 0, 0, 0. For hexadecimal, my number line is 1, 2, 4, 8. Here, 1, 2, 4, 8. So our first hex value, 8 plus 4 plus 2 plus 1, 15, which gives us F. And here we have 8. There you go, F8. Or we could write it 0x to tell us that this is hexadecimal. Question here, and then you. Because, right, just these, right? Only the 8 is on.
Oh, okay. That makes sense.
Newton?
So the highest number you can do is 255?
Yep, the highest decimal is 255. What would the highest hex value be? F. The highest binary value is 1. Why and 2? It does not go beyond F, no. Because you only work with 4 bits, right? So if I turn on all 4 of these bits, That equals 15. I don't have any more bits that I can use. I'm limited to 4.
So the reason you change it into binary first is so that you can know what's on.
Yeah, so you know the value of the bits. Question?
Can you just repeat what the top one is called again?
This up here?
No, like the 1, 2, 4, 8, 16, 32.
Binary. This is our number line, right? These values. This is binary. The ones and zeros is binary, decimal, hexadecimal.
Binary works in bits, right?
Bits, yep, ones and zeros. We'll do one more thing. So I know we talked about, let me turn those TVs on. We talked about not playing games in here. I lied. There is one game I will allow you to play on Cisco.
If I don't make board next month, I'm gonna apply for SkillBridge. And that SkillBridge will start a week after graduation.
All right. So if you go to, let me push this out. If you go to a web browser of your choice, like Google, and search Cisco, binary game. Click that there. Play game. And look at that. It's got our numbers here. So how do we get 128? Just the 128 on. And what about for this 4 here? Turn off the 8. Turn on the 4. 255 is all bits turned on. 64, just the 64. 128, 128. 255, all turned on. 8, turn off the 128, turn on the 8. 2, 255. 15, we know is everything left, right of 16, etc. Easy day? All right. Any questions on this? So feel free to play this game anytime you want in class. And we'll see, my last class made it all the way up to the highest someone made it was completing level 7.